So in the previous video, I gave you a few examples on differentiating simple single term functions. What I'm going to do in this video is work you through the solutions of all of these so you can check them, make sure you're on the right track, and take it forward from there. So here are the questions again, just a quick refresher for you. Calculate the following derivatives with respect to their given variable. So first one was f of x equals x to the 7. Second was f of x equals 12x to the power of 4. Third was y equals negative 3x to the power of 6. And the fourth was f of p equals negative p to the power of 3. So let's see how we crack these out. First one, f of x equals x to the power of 7. Now remember the general steps we said for taking the derivative of a function like this. Take the power, we stick it in front, we reduce the power by 1. The only thing that really changes at this stage is if there's a coefficient, but there is none here. The only other thing we have to really be careful of is our notation for the derivative. Now we're told f of x equals this, so a function with respect to x equals that. Remember, for taking the derivative, it becomes f dashed x equals. Always do that with our derivative when it's f of x for these sorts of questions. So what we said, power down in front, reduce the power by 1. So that becomes 7x to the power of 6. Job done. Second one, f of x equals 12x to the power of 4. Again, an f of x for taking the derivative is noted the same. F dashed of x equals 12x to the power of 4. So we've got a coefficient this time. So first thing we do is write the coefficient down. It's 12. And then do our derivative steps on these parts here. So it's x to the power of 4. Bring the 4 down, reduce the power by 1. So it's 12 times 4x to the power of 3, 4x cubed. We then simplify what we can. So 12 times 4, I hope you could do that by now, is 48. So it becomes 48x to the power of 3. Taking the derivative of that one is still fairly straightforward. Yeah, the coefficient adds in one extra step, but I'd hope by now 12 times 4 wasn't too much beyond you. Third example we had was y equals negative 3x to the 6. Again, these are the same steps. It's got a coefficient, so we're going to write that down and then bring the power down, reduce it by 1, simplify when we can. The big difference though is this, it's y equals. Now remember, if it's something like y equals, we have to state the derivative in a slightly different way. And in this case, it's dy by dx. So what this means is derivative of y with respect to x. So we note it this way. But the steps here don't change. We still write down our coefficient, negative 3, and then multiply it by our derivative part. So power down in front, reduce the power by 1. So it becomes 6x to the power of 5. We then simplify as much as we can. Negative 3 times 6 is negative 18, x to the power of 5. Job done, we're there. Fourth and final example was f of p equals negative p to the power of 3. Now think back to the original question. It said take the derivative with respect to the given variable. Well, in this case, all I've done that's different is instead of x, I've put p. It's not going to change any of the steps we do. We look at this first, put our coefficients down, do the exact same steps. And again, the only thing that changes from the f dashed of x in the previous examples is in this one, it becomes f dashed of p rather than f dashed of x. So our coefficient here, well, it's negative p, so our coefficient there is technically negative 1. So we could put that down and then multiply it by the derivative part here. Bring the power down, reduce it by 1, with 3p squared. And it's then just a case of simplifying it, and I get negative 3p squared. Job done there. So it's the same set of steps in each of them. It's a fairly straightforward technique when it's single terms and breaking them down. Even when we start to up the complexity, it still doesn't get too much more complicated as long as we remember these general steps.